This video is all about parabolas. So again, we're just going to be using what we quickly reviewed in our last video, which is how to find things like the vertex or the focus or the directrix and so on. And then we will look at the sketch of the graph, but I'm not super concerned that you can graph it yourself. I'm more concerned that you can choose the correct graph out of a lineup. Let's look at our first example together, and what we want to do is, it only asks for the vertex, focus, and directrix, but it also asks us to sketch. So really what I'm going to do is go through all of these things, the axis of symmetry, the directrix, the focus, the lattice rectum. We're going to do them all. So what we would do first is notice that I've given you this equation not in the standard form. Not the standard equation of a parabola, but just the general form, which isn't super helpful. So now we have to do some work. And when I do the work, again, I'm trying to turn it into this form so that I can identify h and k and p. So that's what I need to identify is h and k and p, because those are all of the values I need to find everything. And in order to do that, I of course need it in the correct form. So I'm going to write x squared minus 2x and leave myself a little bit of space. And then I'm going to move everything else to the opposite side by adding 4y to each side and adding 7 to each side. So 4y plus 7. And I'm actually going to take away that plus blank and make it a different color. And so whenever I'm doing this, what I'm trying to do is complete the square on the left-hand side of the equation. So again, everything in this video is all review of things you've learned in other classes. So you should have already learned about a parabola and you should have learned how to complete the square, but these are things that you may have forgotten. So to complete the square, every single time we're going to add to each side b divided by 2 quantity squared. And you might be thinking, hold up, where's b come from? Well, we know that a quadratic, which is what I have on the left-hand side, is in the form ax squared plus bx plus c. So essentially, I'm finding c. And I'm going to do that by taking b, dividing it by 2, and squaring it. So this is going to give me negative 2 over 2 squared, which is negative 1 squared, which is positive 1. Now this value is going to be very important, so whatever you end up squaring, just remember what value that is. So what I have now is I'm going to add 1 here and add 1 here. That gives me x squared minus 2x plus 1 is equal to 4y plus 8. Now, why did I make a big deal about the negative 1? Well, because now what I have on the left-hand side of my equation is a perfect square trinomial. And a perfect square trinomial can be rewritten as the square root of the first value and then plus or minus the square root of the last value, quantity squared. And so notice negative 1, negative 1. That will always be the case. So the left-hand side is x minus 1 quantity squared. The right-hand side, I want to also write it in this form. So 4p times the quantity of y minus k. So basically whatever I can take out, which in this case is just 4, and then y plus 2. So let's identify what we can identify now. I can identify that this value is h. So h is 1. I know, based on, again, this equation, that 4 is equal to 4p, and therefore p must be 1. So p is 1. And I know that positive 2 is not k, but that negative 2 is k, because I'm expecting the value to be minus. So I've subtracted a negative 2. So again, k is negative 2. So using those values, we're going to find everything we need to find. And we will graph them as we go. So here's my graph. It's not going to be a pretty graph, and it doesn't have to be, because really I'm just going to have you do a multiple choice which graph is which type of situation, so you won't have to graph it. But let's go ahead and take a look at what I can find. What we should start with is the vertex. So the vertex can be found by taking h comma k, which is 1 comma negative 2. So 1 comma negative 2 is my vertex. My axis of symmetry is x equals h. X equals h is x equals 1. And again, that's the equation of a line. So that should be a line at x equals 1. And typically the axis of symmetry is drawn as a dotted line. The next is the directrix. The directrix is also a line. Y is equal to k minus p, which is negative 2 minus 1, or negative 3. Y equals negative 3 would be this line right here. And remember, the significance of the directrix is that every point on our parabola is equidistant from the directrix and the focus. So that brings us to the focus. The focus is h, which is 1, comma k plus p, negative 2 plus 1, or 1 comma negative 1. So 1 comma negative 1 is right here. That's my focus. I'm going to go ahead and put a V next to this guy. And then the last thing I want to find is the lattice rectum. And that is 2 different points. So this is just going to give me the end points of the lattice rectum, which is h, or 1, plus or minus 2 times p, which is 2 times 1, comma k plus p. So k is negative 2, p is 1. So that's going to give me 2 values. The first is 1 plus 2 times 1, or 1 plus 2, which is 3, comma negative 2 plus 1. And the second is 1 minus 2 times 1, or 1 minus 2, which is negative 1, comma negative 2 plus 1, which is negative 1. So I have the point 1, 2, 3, negative 1, and negative 1, negative 1. And so what does my graph look like? Well, it's going to start at the vertex, or that's going to be our lowest point, and I'm just going to go through the 2 values that I find for my lattice rectum. So I could be more precise about it, but that's going to be plenty. Let's do another example now going in the opposite direction. So the first example, we had our standard parabola that opens up or down. Now, as you can see, I've got a y squared value instead of an x squared value, which means my graph's either going to look like this somewhat or like that. So let's see what we come up with. We're going to start the exact same way. So I have y squared plus 6y. I'm going to leave a space. And then I'm going to subtract 8x from each side and subtract 25 from each side. And then I'm leaving space for that plus blank. And remember, the blank is b over 2 quantity squared, which in this case would be 6 over 2 quantity squared, or 3 squared, keeping in mind that that 3 is important, which is 9. So I'm going to add a 9 to each side. But the reason the 3 was important is because now I can write the left side as y plus 3 quantity squared, since it is a perfect square trinomial. On the right side, I have negative 8x, and then I have negative 25 plus 9, or negative 16. So the last step is to factor out whatever I need to factor out. So this gives me y plus 3 quantity squared is equal to negative 8. If I take out negative 8, that gives me x plus 2 left over. Let's identify the h and the k and the p value. So y minus k would be that k is negative 3. X minus h would be that h is negative 2. And negative 8 is equal to 4p and therefore dividing by 4, I would get -2 is equal to p. So there's my values. I'm just going to write it a little bit further up. P is equal to -2. So from here, I'm just going to do exactly what I did last time. I'm going to graph this and see what my parabola would look like. And so I would start by finding the vertex. And the vertex is HK, which is -2, -3. So -2, -3 is about right there. Then I will find the axis of symmetry, which for one going right to left is y equals k, or y equals -3. So that's going to be that dotted line that goes through the vertex that I would be able to fold my parabola in half across. Then let's find the directrix. The directrix is also the equation of a line. It is x equals h minus p, -2 minus -2, and that's x equals 0. That's this line right here. And remember, that's going to be the same distance from the vertex as the focus. So let's now find the focus. The focus is h plus p, so that's -2 plus -2, comma k, which is -4, comma -3. So -4, -3 is the focus. And again, I can see that the vertex is the same distance from the focus and the directrix. The last thing we would do is find the length of the lattice rectum, and that is going to be, or the endpoints, excuse me, of the lattice rectum, and that is h plus p, so -2 plus -2, comma k, which is -3, plus or minus 2 times -2, and that should give me 2 ordered pairs. So the first is -2 plus -2, which is -4, comma -3 plus -4, and then the other is -4 and -3 minus -4, or -3 plus 4, which is 1. So I have -4, -7, 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, somewhere down here. Sorry, I shorted you a little bit. And then -4, 1, which is -4, 1. So that's this distance. And then to draw the picture, I would go through those points as well as the vertex. And again, it's just a rough sketch. We didn't find any other exact points besides those 2 values of the lattice rectum and the vertex. You might also be given some characteristics of a parabola and be asked to write the standard form of the equation. And you can do this a couple of different ways. You can, if you're a very visual person, you can plot the 2 values that you are given on your graph, and then take what you know about those values to determine everything else about the standard form. Or you can do it the mathy way, which is of course to look at h, k, and p based on the values that you're given. So the first thing I would do in this case is notice that the directrix is x is equal to -2, which means this is not a vertical axis, but it's a horizontal axis question, because that is the format of the directrix. So I know that h minus p is equal to -2, because that's what the directrix tells me. And the focus is h plus p, comma k. So this tells me that k is equal to 2, and h plus p is equal to 2. So I should be able to do a little bit of math here and find out that 2h is equal to 0, so h must be equal to 0. And the only thing I have left to solve for is p, And so if h plus p is equal to 2 and h is 0, then p must be 2. So I have now found each of my variables. The question says, find the standard form of the equation. So I'm just going to use what I know and plug them right into that equation. So that is y minus k, which is 2, quantity squared, is equal to 4p, so 4 times 2, which is 8. And you can write it as 8 or 4 times 2. And then x minus h, so x minus 0, quantity squared, or of course y minus 2 quantity squared is equal to 8x squared. Up next, we're going to take a closer look at ellipses.